I think most of us know you, Kavan, but let me ask a few questions as an introduction. So, as your first slide states, you're an astronomer. You worked in NASA at some time ago, and now you're happily retired back into Sri Lanka. So, why have you chosen to talk about natural disasters? What has astronomy got to do with natural disasters?
Okay, I'm talking mostly on the geological time scale. So astronomy is quite related, and quite a lot of the natural disasters of a few 100 million years ago may have happened caused by astronomical events. And I want, and I'm talking about the history of the Earth as such from the beginning. And I think a lot of people tell some things many of us don't really know about. I didn't know about it till I sort of found out about 10 years ago. I definitely didn't learn about it in school.
Exactly. It's time for all of us to know about these things, how it happens, or at least the theories on how it happens, with a view to stop them or control them if we can to some extent. Without further ado, I'll open the forum to you. You can start your lecture now, Carmen.
Thank you for inviting me. I think I'm talking about events on the history of Earth from the time it originally formed 4.5 billion years ago. And I think quite a lot of the events I don't think are even mentioned in any school curriculum. And now, I guess over the last 50 years, we have got a lot of understanding of the history of the Earth from its start, which a lot of us didn't learn at school. Maybe I don't think that it's even taught in school now. So we have the Earth, round Earth, with Sri Lanka mostly covered quite often by clouds, unfortunately by a bit too much. But I will, in most of my slides, I will be showing the Earth like this. It's not that I have made it elongated, but it's just a way of seeing the whole Earth. It's a height of projection, which is sort of better than the normal flat screen that we see. Okay, so the Earth is covered with a lot of plates. I mean, this is tectonic plates. It's a lot of individual things which slide around each other. And there is about 7 or 8 plates that we have well identified. And Sri Lanka, luckily, is in the middle of one of them rather than at the edge. And these plates move around with time. And how do we know about the plates? Is because earthquakes happen close to the borders of plates. So this is a picture of the earthquakes in a 25-year period. And we see all the earthquakes happening along the border of the plates, plate tectonics, and that identifies what the plates are. We are luckily not close to a plate, but there is a plate here sort of forming here, which will separate us from the Australia plate and might cause us some problems. But these are in geological times. That is basically below the Earth, there is convection cells of the mantle. And in this case, you have North America and Europe moving away from each other. They are moving away now politically, but this is literally moving away from each other for millions of years, separating the American plate with the European plate. Now, when plates move, it creates earthquakes and subsequent tsunamis like we had in 2004 December. But those things don't really threaten life on Earth. I mean, life on Earth continues after all that sort of natural disasters. I'm talking about bigger things which can harm all of life in general, not just human life on Earth. So I'm talking about, I will initially talk about global extinctions and of life on Earth over geological timescales. Now, when talking about geological timescales, I just want to make everybody familiar with what these timescales are. Now, the universe is 13.8 billion years. The Earth is 4.6 billion years. Life on Earth started very soon after. It's about 3.8 billion years old. Plants and animals, 530 million years. Extinction of dinosaurs, about 65 million years. Human evolution, about 200,000 years. Recorded history, 6,000 years. And our lifespan is 100 years. The problem is when you look at that, lot many people don't know the difference in time of 100 years compared to 13.8 billion or a billion years. And to make that clearer, using Carl Sagan's beautiful illustration, if you compare the Earth to be 1 year, then 13.8 billion is 1 year, 1 month is 1.15 million, a day is 38 million, an hour is 1.5 million, a minute is 26,000, and 1 cosmic second is 438 years. So if you comparison to a year to be the age of the universe, a second is 438 years. So therefore, our civilization, what we talk about as if it's a huge important part of our history of the Earth, is just 10 cosmic seconds, just a flash which could get forgotten if the things go wrong for us. Human race is about 200,000 years old, so even that is the evolution of anatomically modern humans are about 8 cosmic minutes. And dinosaurs went extinct just 2 cosmic days ago. So this perspective that we are huge and a huge impact on Earth is actually we are just a flash when you consider the Earth. So let's consider the Earth. Earth started about 5 billion years ago, contracting from a thing, formed the solar system. And our history from 4,500 years from in the past to now is divided into various periods of time depending on evolution of life on Earth. From the beginning, Hadrian and the Archean, Paleolithic, and the other eras were marked out there. There were biological events that happened during that time, evolution, and then there is also physical events. And one of the things that is right up there in the top left-hand corner is the forming of the moon. Now, many people would have thought that the moon would have just formed, but no, it did not form. It was actually the first accident or the huge impact that happened when an object named Theia, it has been given a name, the size of Mars, struck the young Earth with a glancing blow. So that would have been a horrific thing to happen. Luckily, we didn't burst open and get destroyed entirely. But Theia created a huge thing. All the stuff was thrown out of the Earth and started going orbiting the Earth. And finally, that all the debris created the moon, which is something I'm sure you all may not have known. And how do we know or confirm this theory was the fact that most of the moon rocks that were brought back from Apollo 11 looked just like the material from the Earth's mantle. There was actually not much difference, and that gave rise to a proof or reasonable proof that this theory must be correct. There are a lot of other evidences. I'm not going through into it. So initially we had a very hot Earth. It has sort of molten, and the moon was actually a lot colder, and the Earth's revolution was about 10 hours rather than 24 hours. Over the last 4 billion years, the moon has slowed the Earth's rotation round and then moved further out. So that is sort of, in a way, part of the moon being formed would have helped to create tides, which are part of the evolutionary process as well. If there was no tides on Earth, maybe we wouldn't have had so much of interesting evolution. I don't know why this is moving on its own. Okay. Okay, so the first life forms, the single cellular stuff, started from 3.9 to 2.5 billion years. Life forms somewhere around from 2.5 billion to 0.5 half a billion years. There were multicellular life, but during that time, there was the Earth was quite different to us. All the plate tectonics, basically, if you push them back to what they were a billion years ago, there was a huge landmass called Rodinia. All these landmasses have been given names, and it is the oldest known supercontinent. Rodinia sort of broke up due to plate tectonics somewhere around 770 million years ago. And that was the next problem. The details I'm not going to go through, but as the breakup created a different atmosphere, created heat and carbon dioxide, and that trapped the Earth light, and we ended up very cold. Average global temperatures plummeted to minus 50 degrees centigrade Celsius. And we were really in a pretty bad shape, and the Earth looked like a snowball. Not much life could have evolved there from 720 to 635 million years. That's what the Earth looked like, completely covered with about a kilometer of snow. And all the water was frozen. There was no rain. And therefore, in a way that create one of the ways that it came out of the snowball Earth is the fact that since there were no rainfall, it couldn't get rid of the carbon dioxide which was emitted by all the volcanoes during that time. The carbon dioxide accumulated and the planet quietly warmed up and the sea ice slowly thinned and we got started again. Took about 85 million years for this to come back. Carbon dioxide concentration went up by about 1,000-fold. We got and the warm planet. We got the thawing of the snowball. Temperatures went up to about 50 degrees centigrade, and we were back in business. I think that long period various things must have happened, that there was a huge amount of evolution that happened soon after. For 650 million years ago, this is what the Earth looked like, quite different from what we have. People have marked little parts of what we think where those parts of India and Australia and all were in that landmass of 650 million years ago. 514, then there was this, what is well known, a lot of people have heard about the Gondwana land, which was a large landmass about 500 million years. And there was an enormous amount of life that generated soon after. There was a sort of explosion of life forms in the ocean because maybe the 85 billion years under ice helped in the transformation, but soon afterwards, there was an explosion of life. Now, get to the talk of extinctions. People have studied these things, what life forms were there when they got destroyed, and clearly identify about 5 events during the last 600 million years where a lot of life on Earth completely got almost destroyed and almost ended. And most of I showed you a picture previously of time durations, and most of the boundaries of those times are defined by these extinction events. Maybe there is another one coming when we have a nuclear war, but other than that, these are natural things that created and destroyed most of the life on Earth. This is an old plot I had got, and recently I managed to get another plot, which is got from marine animals that were destroyed. I think the people can get core samples from the sea and work this out much more clearly and probably more logically than the land one, which has got eroded by rain. So the sea ones, this is life forms destroyed in the sea. Those same 5 peaks are shown where more than 75% of all life forms were made extinct by some event. There were a lot of smaller events, but what they are is difficult to say. So over the 600 million years, we have lost 5 times, we have lost 75% of the species. And all these events are far beyond human control, but happens on a very large time scale. But what has to be recognized that some of them were vital for the evolution of man on Earth. So we were helped by some of those events. Okay. So this is 425 million years ago. That was what the ocean looked like. Quite things what we normally see, the bites and in the ocean floor. These are some fossilized evidence. I'm sure those of you who have gone to various tourist places, this is sort of thing is so common that you can buy these little fossilized life forms for about few dollars. They are not very expensive because there are so large numbers are found of them. So I also have a few. I show them during the chat. Okay, now what could have happened? One of the astronomical things that we are talking about, which could have destroyed life on Earth, are what is called gamma ray bursts. They happen in a galaxy the size of our galaxy, about 2 events per billion years. So we could have well expected at least one of them to happen in the 500 or 600 million year time scale that we were discussing after a huge explosion of life forms. And one of those things may be the Ardevian sort of event, which is claimed now to be caused by a galactic gravitation gamma ray burst. These are gamma ray bursts which happen when two neutron stars come together and join up to create a black hole, or a large massive star contracts to create a black hole. Both events can create a black hole in the final thing, and in the process can give a burst of gamma rays. Now, these gamma rays are frequently observed now. I think there are gamma rays observed every day by orbiting telescopes. In fact, when the first gamma rays were detected, they were detected by satellites which were put up there to see whether Russia was exploding anything dangerous. And they luckily discovered that these bursts were not coming from the Earth, but were coming from outer space and luckily didn't start a third world war in the process. But now they are studied. I mean, gamma ray astronomy is well established, and we have followed up observing the location which the gamma ray burst came from, and have seen galaxies emitting the gamma ray burst. So it's a interesting study, but those happen on a galaxy like the Milky Way twice in a billion years. Billion, not million. Okay. So a lot of characteristics of that thing: extinction of shallow water organisms, yes. Extinction of free swimming organisms, yes. Extinction of surface plankton, yes. Nitric acid rain and reduction of solar radiation. So all these things match up with what we saw in that transition, and now there is quite positive evidence that must have been a gamma ray burst. So after that, we had different life forms in the ocean. And there's another thing that can destroy life on Earth. Those are supernova explosions near to the Earth. Those happen about 2 supernovas are expected per century. They're normally far away and spectacular, but harmless. But if they happen nearby, then there could be a lot of damage done to life on Earth. The supernovas that we know of, unfortunately, we have not had a bright supernova of our galaxy recently. But the first one was observed by Tycho Brahe in 1572 when he was a guy who knew all the stars in the sky. And then one evening he saw a bright star, and he saw the 1572 supernova, which he sort of described, didn't know what it was, but now we know what this sort of thing is. So if a supernova happens within 30 light years from us, then we would basically get a lot of biological damage because of the radiation that can come. The biggest supernova, nearest supernova over the we can remember was 1987A, which happened in the Large Magellanic Cloud, and that's about 160,000 light years away. So it didn't affect us. We saw a bright star which became very bright in the southern hemisphere. But other than that, it didn't do much any damage. We were able to detect things that came from it. But this sort of supernova would have created damage to DNA. And in a way, it may be helping evolution because DNA damage means that you get lots of other possibilities and change in the DNA structure, which would have created some animals which would have had better survival instincts and some animals which would have died off immediately. So in a way, these things may be helping evolution in a way. But we don't want to have anything happening close by to destroy us. Luckily, there is no supernova in the next average occur every 250 million years, but we don't know of anything. Astronomers would have known if there were massive O and B or M star supergiants nearby. Yes? Nearby, which will go supernova, but we don't know of any of that nature, so we are lucky. And hopefully there won't. The only one that people were hoping was Betelgeuse in Orion Nebula is sort of will go supernova, and there was a lot of talk, it's going to go next year, sort of thing. Next year in geological time, maybe 50,000 years in the future or 1,000 years in the future. So even though there was indications that it might explode as a supernova, it would be fascinating if it does. It may not be in our lifetime. But nothing, those are much further than 30 light years, so nothing to fear even if it goes supernova. Okay. So 150 million years ago, this was what the Earth looked like. Gondwana land was there. India was separated out from Asia and sticking out next to Antarctica and Africa and Australia. And that was what it was like at that time. About 66 million years ago, then things have moved apart and that Gondwana land have broken up, and it's now more familiar to what the Earth looks like now. There was India was separate from the Asia. When this moved forward along and struck Asia is what created the Himalayas. Other than that, rest of the world looks not too much different from us today. Okay. Around 64 million, 65 million years ago, when the Earth looked like that, we had a huge accident where an object hit us in Yucatan, right here, around here. Now we know the location. It was located quite clearly that this happened around 64 million years ago. And the impact of that event, 65 million years ago, of a 4.4 to 6 kilometer asteroid striking the Yucatan Peninsula in Mexico, killed off all the dinosaurs. So if all the dinosaurs were not killed off then, the Earth would have still most probably 65 million years in not a long time, would have been still running with dinosaurs running around the Earth, and humans mammals as such, would not have developed, and then finally humans wouldn't have come around. So in a way, I don't know, the KT event, whether it's a good or bad thing, it killed off. It was an extinction event, but it was beneficial for human evolution, if that is what we are destined to happen. Craters like what happened there, we can see that most of that crater is underwater and eroded. We see craters like this on the surface of the Earth. This is meteor crater in Arizona, which has happened only 50,000 years ago. So it has not had much time to erode and get disappeared. There are lots of craters that are visible on Earth, but most are not as clearly as this. This must be the last large one. There were other accidents of small items, maybe 60 to 100 meters, which have collided with the Earth. And the last big one, like this, was in 1908, June 30th, when there was a burst over Siberia. And we know it was a burst in the sky because all the trees of that area for 25 kilometer radius all spread out and fell to the ground like this, away from the burst. So that was something that happens also. And there was a small one a couple of years ago, but nothing major, not as large as this. And what we have now in Siberia is a huge grass plain where that impact happened. All the trees having been destroyed about 120 years ago. So if you think of impacts like that, which is quite harmful to us, if you take the energy, and this is increasing energy, we have this KT event, which has happened 65 million years ago. That happens on the time scale of about 1 in 100 million years. We have Tunguska happening in a time scale of about once in 1,000 years. Meteor crater happening in about once in 100,000 years. And then there are smaller things happening further on. If you on that times on the size of destruction, a nuclear winter would be about that. And if all the world's arsenal were exploded, then it would be slightly bigger, but it's still not as large as what a KT event would be. And it's sort of meteor crater is sort of, this is a logarithmic scale, so maybe order of magnitude less. Okay, those who think that that sort of accidents don't happen, we actually saw one in 1994, not on Earth, but we actually saw a comet hit Jupiter. And I can remember I was at Johns Hopkins University and looking at these images through a telescope. And there were these huge patches that were seen on Jupiter. And this is in comparison the size of the Earth. Jupiter is so much larger than the Earth. These patches that were created by this impact is about the same size as the Earth. So something like that hitting the Earth would be quite devastating. And so we did see what happens when items thing. This is the only thing that we have observed like this, not luckily not on Earth, but on other planets. So meteor strikes can happen, local destruction on 1,000-year timescales, global mass extinctions on the 100-million-year timescale. NASA Goddard is now creating something called Space Guard, which is trying to find every asteroid larger than 140 meters, which can hit us. So hopefully we can then stop them if we have enough warning of something like that coming across and hitting a dangerous part. If it hits the sea, it will create very large tsunamis, which will be dangerous to the coastal areas. And if it hits the earth and if it hits a city, then that city is destroyed entirely. Because even a small one about 50 kilometers, you see the destruction that it did in Siberia. Such a thing going to hit us maybe with about a 5 to 10 year time scale. then we could probably send up a rocket or a satellite basically to the neighborhood of the asteroid that is might strike us and push it away a tiny bit so that it may swing past us and not really have an impact. If you have a sufficiently large number of years lead time, then you have to only change a tiny bit of the orbit to stop it striking us. There is some, I'm sure you would have read in the newspapers various stories about, there is an asteroid going to hit us in 5 years' time, there's an asteroid going to hit us in 10 years' time. And all those stories disappear from the news. Unfortunately, they don't say that it's no longer going to hit us after it becomes not. They only tell when it is about to hit us, is sort of scheduled to hit us. And when the better observations say that it's not, that never gets into the news. So I was asked, isn't there something going to hit us in 2036? And I said, no, that has gone away, and that went away 2 years ago, but nobody knows that it went away. Okay. Now, another thing, which is something I heard about recently, and I think it's based on research that was done in 2023. So it's a fairly new thing. I didn't know about it till I was reading up about something else. And this was that there was a fairly change in our weather somewhere around 1 million years ago. Not more recently, it was 1 million years ago. Anatomically modern human was not evolving, but humans as such were evolving through various stages at that time. So somewhere around 1 million years ago, apparently the ice ages changed from a cycle of about 41,000 years to roughly 100,000 years. And that created a lot of problems for life or primitive human primate life on Earth. And this is called the mid-Pleistocene transition, MPT, occurring between, had a peak around 900.9 million years ago. Okay. Because this is caused by various changes in our orbit, I have used the Earth's orbit around the sun can change slightly from an eccentricity of 0.167, which is 0.167, which is the current eccentricity, to practically zero at 0.005, and sometimes becomes slightly more elliptic, which eccentricity of 0.058, which means that there would have been a change of about 10% between the nearest and the furthest thing. So this is a non-exaggerated graph of what the two small changes are. Then there are small changes in the tilt of the axis of rotation from about 24.5 to about 22.1. And then there's also the precession of the ecliptic at the top, which changes the polarity. So all these combine. And if you look at it, you get the eccentricity changing over a time scale of 100,000 years to 400,000 years. The obliquity, which is the inclination, changing at about 41,000 years. And precession, which changes at about 20,000 to 23,000 years. So these two, at the extreme range, we have a difference of plus or minus about 6% in the distance to the sun. That's a change about 17.3 million. Recently, I got a stupid WhatsApp message which said, "Oh, the Earth's distance to the sun changes from 150 million years to 90 million years." I couldn't understand it. The guy sent crap and it gets forwarded by lots of people, unfortunately. Anyway, it doesn't change very much. But the consequence of all those little changes is there are various changes in the solar radiation that is coming up. So you have precession creating a sort of a curve like this, obliquity changing, slight small changes, eccentricity doing some changes. And subsequently, now there is about 100,000 year cycles when we have ice ages and warming periods. So this is the sort of stages of our ice ages. The last one, which ended about 15,000 years ago, when we have been warming ever since then. So what did that bottleneck do? It is used to explain that humans have only about 0.1% genetic diversity in the nucleotides, whereas chimpanzees, which are much smaller population, has about 0.25% diversity. And that people have interpreted, and with modeling said that there was about a million, 600,000, 900,000 years ago, there was a sharp reduction in the population of the Earth. And that at that time, I don't know how they can tell it so exactly, they say there was only 1,300 breeding individuals in the world. So the population of the Earth would have been around 5,000 humans, not humans, but primates. And that happened, and that lasted from about 630,000 years to 810,000 years. So this is all statistical modeling of the DNA that has shown this. They see how variations happen, extra bits of changes in the DNA, and the fact that we don't have. And they say that around that time, the number of chromosomes changed from 47, which chimpanzees have 47, and we have 46 because a set of chromosomes joined together. So I'm sure the medical people know a lot more of this subject than I do. But that I found was interesting, that we went through a very sharp period where we may have gone extinct if those 1,300 people didn't survive about 100,000, 120,000 years. Okay. So let's now talk about various other disasters that can happen in our lifetime. I think one of the big ones, which we don't know when will happen, is the reversal of the poles. The north and the south interchange. We are used to the north being north and the south being north. Actually, the north pole of the Earth is pointing south at the moment, because that's why all the compasses, the northern pointing compasses, point to the South Pole, because opposites attract. So that's the way it is, but this can reverse at a time scale of about a couple of 100,000 years. How do we know that the reversals have happened over the last so many million years? Is because the magma, which has a lot of iron in it, come up from the mid-Atlantic ridge, and they flow outwards. And then you can go and measure the directionality of the material that has come out, because during the time that it is molten, it will rotate preferably towards the poles, on the magnetic part of it. And you can measure those things. And so each of these reversals, this is when the polarity was reversed from current day. You can actually measure the reversals of polarity over the period and estimate when that happened. So that's quite an interesting study. We have got over the last million years or so what the changes in magnetism was. We even have one recently, because the current magnetic field is reducing over the last few thousand years. And hopefully that will not lead up to a flip in the Earth's magnetic pole reversal. Interesting, in the sun, the magnetic poles reverse every 22 years. So something that happens very regularly every 22 years, but on Earth, luckily, it happens only in many thousands of years, hundreds of thousands of years, and it may not be too much of a danger for us now. But what will happen if the magnetic poles reverse? And that is is that the Earth, another thing that evolution required, because of the large magnetic dipole in the center of the Earth, we have what is known as Van Allen belts, which were discovered in 1957 when we sent our first rockets into space. And that protects the Earth from solar wind. So that is, so if there's a huge ejection of coronal wind from the sun, then it comes and hits the Earth in about 3 or 4 days, 2 to 4 days. And that is protected only because we have this huge magnetosphere around the Earth, which traps all those particles, and except for a small amount leaking through the northern and the southern times, this is weak because this part is well protected, the equator is well protected, but a certain amount can leak through the north and the south poles, and that's what creates these beautiful northern lights and southern lights when there is a big storm, and those are beautiful things to see. This is at a time when you have that area of the Earth would be covered and predicted with things. If you have not seen northern lights and southern lights, I have not seen it myself. I missed a big storm by 1 week when I was in North America, but left a week before. If I had known, I would have definitely waited, but you can't predict these a week ahead. And if they do happen, then it is quite spectacular. I'm sure some of you all may have seen the Northern Lights. It's worth something traveling to go and actually see, but you have to predict the correct time. If not, you're not going to see anything. So these are the beautiful Northern Lights. I've only seen red when I was in Victoria, Canada, for one night when it was illuminated, but never, I have not seen these curtains, which is what is beautiful to see. So beautiful stuff to see in Alaska if you're in the correct time. This is actually the correct part of the solar cycle to actually see this. But there is another problem. If a large solar storm hits us, like hit us with an event called the Carrington event of 1859, September 1st, then it will do a huge amount of damage to our internet and all the infrastructure we have on Earth. A large event like that, those events have been observed from space. There was one in 2012, which was observed from Space Observatory, but luckily was not directed towards the Earth. The probability of one of those events hitting the Earth is about once in a century, but it would enormously stop ourselves. In 2013, they did a joint venture with Lloyd's, who wanted to discuss what that would do. And in 2013, they estimated that the US alone would have a damage to the cost of $1 trillion damage. And it depends on where it hits, but if it hit the US, that was the estimate. It could hit somewhere on Earth. If it hits the ocean, it will be less of a problem. But this is something that there was a study in the United States to say, can we protect ourselves against it? You can't prevent it, but can we protect ourselves so that we won't get so much damage? But with the current things of the Trump administration, I don't think this funding, that sort of protection or changing is going to happen. So if it happens, then it will be considered God's action or something like that, and we would suffer the huge consequences. But it could wipe out a whole part of the world if that happens. Okay. Other things that have been historically creating lots of natural problems to us are volcanoes. This is what happened in the most famous volcano in Pompeii in 79 AD, which covered the covered whole of Pompeii. And if you go to Pompeii, you see all these little people and these were not actually people entombed. The people actually got destroyed and the flesh, but there were huge cavities where the people were. So when they discovered these cavities were actually people, they poured those cavities with plaster of Paris, and what they dug out was the plaster of Paris cast of the person who had died at that spot. and person or dog. So that's an amazing place. I don't know. I visited Pompeii, must be about 40 years ago, and it is an amazing place to visit. So what happened close to us, Sri Lanka, would be Krakatoa, which exploded in Indonesia in 1883 and put out about 100 million tons of, it's equivalent to 100 million tons of dynamite. Explosion was heard in Sri Lanka. And all the dust got off and generated a tsunami which hit Galle. So that was the last tsunami to hit Galle in 1883. The same things happened that happened during the 2004 tsunami, but memory of what happened and how to protect oneself had lost in the intervening years. So we got a lot of people drowned in that tsunami event, although the tsunami was a lot closer to the Andaman Islands, and they get it much more frequently. And nobody died in Andaman Islands because they knew what to do to run away from the ocean rather than go into the ocean and try to catch fish. So there was another such event which has been talked about. I'm not sure whether this theory has gone away after the thing, but this was what I knew about, which was there was an eruption about 74,000 years ago in a place called Lake Toba. And that explosion created a huge ash cloud. And at that time, they were claiming that there was only 1,000 parents living around that period. I'm not sure whether this particular bottleneck of thing is an independent bottleneck to what has now been found to be happened at 900,000 years, or whether there is an additional bottleneck again here, where we had only about 2,000 parents, 2,000 families, as they say, on the Earth. But I can't see how Toba could have destroyed life right across the Earth. It would have definitely done damage to Asia, but I don't see how it could have done the whole world. So maybe this theory has gone away after the 900,000 year event, which may have been a reflection of the same thing, that people got the time scale wrong. Okay, so there are other similar things that have happened recently. One was in 1980, which was Mount St. Helens, which created an enormous amount of damage to aviation in US, right? But that's very small relatively. So what happened? Well, all these things are basically things that are pent up below the ground, like in Yellowstone, and it will explode at some point in regular intervals. If you have gone to Yellowstone, you see all the geysers which go up regularly every 20, 30 minutes. But these magna explosions happen on a longer scale, and it is very bad. So these are Yellowstone is one of the geologically most active places, and I'll tell you, it's one of the most fascinating places that if you have not visited, you should visit. It's a classic place. Gone there twice. Recently, about 10 years ago, I went there. Okay, so these are basically same as getting a whole lot of water, which is work collected up below in a caldera and then sort of bursts through on a regular capacity. But in addition to that, there is something known as a supervolcano in Yellowstone. And we have had earthquakes recently, but if you look at historically, there is a supervolcano which has gone regularly every 650,000 years. So there was one eruption 2.2 million years ago, which covered all this area of America. There was an eruption 1.3 million years ago, much bit smaller, which happened there. And in eruptions 640 million years ago, sorry, 1,000 years ago, which happened over 0.64 million years ago, which happened over a large area. Now, that sort of thing explodes now. I mean, in fact, the reason it could be over the next 50,000 years or so, not tomorrow, but over the next 50,000 years, it will most probably go up. And that would be quite dangerous. There are quite a few other supervolcanoes, things that could go up. There's Kamchatka, which just made a few years ago, created a volcano starting up there. And there are some other volcanoes around the world. So those are things that we have to watch out for, Iceland particularly, which might destroy. Now, in comparison, if you compare, Mount St. Helens in 1980 is this tiny square, Mount Pinatubo in 1991, which is this big one. Krakatoa, the one that affected Ceylon in 1883, was this bigger volcanic eruption. There was one in 1815. There was one then 760,000 years ago. And this was the big one of Yellowstone, which happened 2.2 million years ago. So one of those happened. We can't stop it, unfortunately. Hopefully we can get pre-warning of it, and will destroy a lot of life on Earth. Maybe if it happens in America, maybe Trump will go with it. Okay. Volcanoes happen around the world. They happen around the same boundaries that there are earthquakes, because, I mean, it's caused by a shallower thing between the mantle and the earth, and therefore those are the places where things will go up. I mean, Sri Lanka has had volcanoes before, but those are in geological timescales, not recently. And we see things like Sigiriya, which would have been a core of a volcano. Okay, so this was what happened 18,000 years ago, where the Earth was pretty much like what we see, and we still had the northern ice age happening, covering most of England and most of Scandinavia, Greenland, and Canada was covered under ice. And this is what it looks like today. Okay. Now I'll talk a bit about global warming, and before I end the talk. Now, over the last 80 million years, this is 80 million years out here to now, the Earth has been cooling from about 6 degrees above what it is now. And somewhere around 40 million years ago, we were about 4 degrees above the current temperatures. And it was the first time that you got Antarctic ice sheet forming. So we know that if we heat the Earth 4 degrees centigrade, over the long term, all of Antarctica would melt. So this is sort of one of the reasons why we know we shouldn't heat the Earth by 4 degrees, because Antarctica will melt. About 2 degrees, we know that there was persistent ice in Antarctica, and the northern hemisphere ice sheets also began around 1 degree. That is sort of, we are gone past that 2 degree warming over the last from industrial revolution time over the last 150 years. And we would most probably get the northern ice over Greenland's melted, and then all the minerals will be there for exploitation, which is what Trump wants to do. And we would have the Antarctica not melting after it goes to 4 degrees, but if it goes to 4 degrees, we are going to be in big trouble. Global temperature has been rising over the last, from the industrial era, very rapidly over the last 50 or 60 years particularly. And if you look at the temperature rise, we find that the northern part of the world where more people live have been the temperature has been rising much faster or more than the southern hemisphere. And that is almost proof that most of this increase in temperature is caused by human activity rather than any natural phenomenon. Because if it was natural phenomenon, the north and the south should be identical because there is nothing except the fact that the south has less land mass, it is more ocean than the north, and that also can have some impact. But human creations have created a lot of heating over the north. But there is also a nice part of global warming because the fact was that whenever we had a warm period, human civilization improved. This was a warm period during the Roman era. We had a lot of civilization. Then we have a dark era. Then we had even in Sri Lanka, Polonnaruwa era, which was a lot of things happening. Anuradhapura era was here, Polonnaruwa era was here. And then we were under the colonial power, and now we are back into a warm era. So in a way, warm eras are not bad. We developed during those periods, but too much warming is going to be a problem. So this is the sea level rise over the last 25 sort of years. It's supposed to be accelerating in rising. And the rise is not uniform. Luckily, near Sri Lanka, it's not much there, but the Pacific sea level has been rising much more, about 10 centimeters, compared to our area. This takes many years to equalize right across the globe. But in a way, this is used by many people when they go and talk about heavy islands going underwater. They do it mostly looking at Pacific islands rather than Maldives, because Maldives has not been so much of a region of increasing sea level. But over a global scale, this is a very graph that one must understand. From about 14,000 years ago, when the ice ages ended last time, all the northern hemisphere ice melted and added to the sea, and we had 120-meter rise in sea level. I mean, that's a huge amount of rise in sea level over a period of about from 14,000 to about 6,000 years. So that period, there was a huge period. People tell that that is sort of remembered as the Great Flood, where all the coastal areas got flooded out over a period of 7,000 years. And now it has been fairly static over the last 6,000 years. And now we are going to start increasing sea levels again. That is what Sri Lanka would have looked like about 5,000 BC, where a lot of people think it's just the Pork Strait, but no, it's not just the Pork Strait or the bridge. It would have been like Florida sticking out of India, with the whole landmass being a part of India. We wouldn't have been a small landmass attached to India by an umbilical cord. We would have been attached fully to India, and there would have been no difference between India and Sri Lanka. This is what it looks like today, where we have a good separation. Unfortunately, maybe in another 1,000 years, we would have half of Sri Lanka going underwater. And that is because if the Greenland melts, right, which is all the ice on Greenland melts, there will be 7-meter increase in sea level. If all of Antarctica melts, which has about 2 kilometers of ice on top of Antarctica, if all that melts, the sea level will go 73 meters up. It will not happen instantly, but over 1,000 years or 2,000 years, we are going to lose all our cities in the coastal areas. And that is something which is important to stop happening. And we can do it if we do some serious amount of action now. May be more difficult to do if we think of starting this action in 100 years. So it is not like the films that they were showing where this happens in a few days. No, it won't happen in a few decades even, but on the time scale of 1,000 years. After all, that 120 meters went up in a time scale of 7,000 years. So I would assume that Antarctica would melt in about 2,000 years completely. It won't melt overnight, but 2,000 years, it is a lot of the country to go underwater. And finally, I will end by showing something which is important to understand about global warming and climate change. It was renamed from global warming to climate change. I think global warming was more what Al Gore talked about. And what is now understood is that the mean increases by a little bit, but a bigger problem is that the dispersion increases, that the range in temperature, because of these changes in the climate and carbon dioxide, the rainfall, wind speed changes more than what it was over the 50% more. The dispersion of all the parameters go up by about 50% over the last century. So we have warmer summers, colder winters, floods, droughts, stronger and wetter cyclones. Weather events that happened once a century now happen every decade, and those that happen once in a decade now happen every year. Basically, with a 50% increase in dispersion, means that 3 sigma events are now 2 sigma and happen more frequently. So this is a nice video I found online which shows what happens with our temperature. This is the distribution of temperature globally. I've asked him to actually do the same graph, north and south separately. But this is 1976. I will start around that. In fact, this goes up from 1951. And you can see that it is flopping around the mean at the middle, not changing very much. The dispersion is maybe increasing a bit, decreasing a bit as the years come on. And from about the 1980s, now this doesn't go cooler anytime, the dispersion is increasing. The colder temperatures are also increasing. The warmer temperatures are increasing. And I mean, the same process goes through to, I don't know how to get back. I'll have to escape this and get to the next slide. I didn't figure out how to get back. Okay, so that's what we are doing to the Earth. And when will the Earth destroy? We will create global warming and everything else. We have lasted through much worse events over the last 4 billion years that Earth will not get destroyed. Humans might no longer be able to live on Earth, and we might get destroyed. We have only been here our civilization has only been here for 10 seconds, so we won't even be noticed when we go. But the sun is going to get destroyed in about 5 billion years when it grows and leaves the main sequence and becomes a red giant star. And it will envelop the Earth, and we will no longer be there. Hopefully, humankind, if we want to survive beyond the 5 billion years, we would have to leave the Earth and go in and explore the rest of our universe, at least our galaxy, get out of the neighborhood of the sun in 5 billion years if humans are to exist. Okay, with that, I will end. I think I took a bit more than half an hour, 1 hour. I hope that you don't mind, and I'll be quite happy to answer any questions on this topic. Okay, Ruan?
Thank you. Thank you very much. If you want to unshare now, there were loads of questions in the chat box. Let's start with them first.
Do I stop share? Okay.
Yeah, stop share. Yeah, yeah.
Okay.
So let's start with some of these questions in order they appeared. Uh, is it Padma? Were the dinosaurs limited only to the Yucatan Peninsula for them to get extinct?
No, they were. It was a global event. We had dinosaurs all the way, yeah, around the world. I think even in Australia, they found Argentina. Whole area world was covered with dinosaurs. But that event was so bad, we had a nuclear winter, or worse than a nuclear winter, where the Earth was covered with ash for maybe 100 or 200 years, and much longer than the lifetime of dinosaurs, and they didn't breed anymore. They were on the top of the food chain, and they didn't survive that. But luckily for us, the little mammals who were at the bottom of the or not at the bottom, is hiding in little burrows and whatever, managed to survive that period of the ice thing and started evolving because there were no big animals to sit and eat them up and destroy. So those mammals took off only after the dinosaurs were killed off. And after that, evolution happened over the last 65 million years, and we came around to about 5 million years ago. We had the first Lucy was there in getting out of trees in Africa.
Thank you very much. And second question is coming from Beatrice Dias. Is there a reversal of the magnetic poles happening now as communicated in various media?
Yeah, because the magnetic field has been going down by a significant amount, they're talking that that could be a reversal. But you have to remember that all these things happen over thousands of years. And if what is happening now may end up in a reversal in 5,000 years' time, but it's very unlikely that it will happen in our lifetime. But we don't know. I mean, we have got records, but we have seen the sort of fluctuation that we see now in that graph I showed you happening even over the last couple of thousand years. So I don't think there's anything to worry. If it happens, we won't go extinct, but we would have a lot of problems communicating and all the things like the Carrington event would happen most probably much more frequently, which cause we won't have the Van Allen bells to look after us.
Then there are two observations from myself in your this regarding to your last few slides. Actually, you put up a slide showing us the mean surface temperature, and I noticed that over Siberia it is much higher than in North America. Why do you think that is the case?
I don't know. I mean, that is a good question. That is a very good question because if it was human created, then
Hmm.
Siberia is the least populated. Maybe it is not local. It's not a local phenomenon. Siberia is so cold, we may sort of, if you are warming something, the coldest parts get warm first before the warmest parts, right? If you warm something in a microwave also you heat attack the coldest things happen. If it is the warming is global, then it is most probably happening in the coldest parts of the world rather than the warmer parts.
And my second observation was on your map. Your predicted Sri Lanka when the water level rises. If you just have a look at it, it's very similar to the Ptolemy's map of Sri Lanka. So I don't know why, because Ptolemy's map didn't have the Jaffna part, and your map was exactly almost reminds me of that.
But Ptolemy's map was much larger. We thought actually, I think Ptolemy's map was talking more like of Borneo rather than Sri Lanka because even
Ah,
the longitude even was for Borneo.
I
And
see.
it and Ptolemy's map cut the equator. We don't cut the equator, whereas Borneo cuts the equator. But there were places marked on that map which were associated with Sri Lanka. That's why we associate that map with Ceylon because there were places. I think the geography of the time really confused places, and we were mixed up with island the size of Borneo, and places were known more for Taprobane. So I think we mixed up, and Ptolemy mixed up the two. By the way, that map was drawn only in the 14th century.
Yeah.
not in 150 BC, 150 AD.
Interestingly, there's somebody from Indonesia here, Giri Nugraha. I don't know whether he or she is still here, whether she or he is a scientist who wants to say something about Indonesia, because that seems to be the place where everything starts. All these, well, many disasters.
Yeah.
This is your chance if you're here, Giri. Well,
Uh,
while he or she is getting ready, we can open up for any other questions. There were a few other questions. Mahendra, go ahead, please.
Uh, Kavan, thank you very much. This is more typical me, I suppose, more philosophical attitude to what you just said now. Uh, many times we have heard about distances and time and how some things are billions of miles away that happen 100 million light years away, and you put on a scale and show you're just a hardly an atom compared to whatever it is, and then that makes you feel small, I suppose, and feel insignificant. But I would suggest that time is not well understood. As you know, there's a theory that time and space are one dimension. And
yes.
as you also know, that time travels differently according to how away you are from Earth, and close you get to Earth, for example, the faster it goes further away, it travels slowly. If you travel very fast, near the speed of light, you can almost not travel. So for me, time is something which is very strange. But for me, when science asks how, we get useful information. When science try to ask why, we get into problems. Then people talk about why, purpose. Is there a purpose? Why is this happening? And then you don't get answers. How, yes. How is useful because if you know how something happens, then you can explain the past and you can possibly prepare for the future by taking action if possible to prevent it. So what I'm trying to say is that do not measure significance in terms of time or distance, right? For me as a human being, my life on this earth is the most significant. It doesn't matter to me 100 at all percent whether the earth lasted so in millions or there's such and such a planet miles away. It doesn't matter at all. For an organism which lives only 6 hours, that will be the most significant time of their life. So don't worry about time, and it's just a man-made construct that we are using. So use it to understand, but don't feel insignificant. All of you are very significant in different ways. So just because we are small, because we exist only a short time, don't think you are insignificant. So that's my message. I don't know what you say, Kavan.
No, I think that is true. I mean, for us, the next 20 years or something is the most important. But I think we are creating ourselves, humans, as being the most important thing that happened to Earth. I think we understanding the history of the Earth right from the start, right? We are part of the evolutionary process, right? We unlikely to be the end of the evolutionary process unless we manage to destroy life on Earth. I think there is most probably life in elsewhere in the universe. But I think we understand how we understand more of ourselves. I mean, all the chemistry and the physics, I mean, astronomy has contributed enormously to our understanding of physics and chemistry and particle physics and everything else. So I think you can't stop understanding the universe if you want to understand more about ourselves, right? It's like you, you exploring the DNA, which is now much more interesting and maybe than astronomy. It's telling us a lot about ourselves and how we evolved over the millions of years, and maybe facts like what has come out now that we were sort of limited to a small number of people a million years ago, or a small number of primates a million years ago, is, I think, in a way interesting. I'm not sure whether you are saying that that knowledge is unimportant for us as a species.
Oh, sorry, Carl, just to interrupt. No, I'm not saying that at all. I'm a great fan of science because science is the only way we can try and make sense of the world. For me, there's no other way. But what I'm saying is don't relate time and distance with significance. So just because we are small, we are not insignificant. So don't worry about significance is something that is man-made and we consider. But don't. But studying, I agree with you completely. We need to understand what happened, what could happen, and so on. So for me, science is central for human understanding. And by no means demeaning what you said about what we know about the Earth and what's going to happen and so on. But I'm only saying this one point about don't think that we are insignificant. I'm not saying you said that, but lots of people say we are insignificant because we are so small and in such a small space of time. Oh my God, you're insignificant. Don't
No,
measure significance by time and dimension. That's my message.
yeah, good, correct.
I think
Any other?
just an anecdote. I think Mahendra's question of whether size matters has been discussed in various different fora as well. Anyway, let's move on to the next question. I think Beatrice, do you want to open up and ask the question rather than reading it out? Beatrice Dias.
Anybody else has put their hands up? I thought there was a hands up.
Well, I don't know who's
Rudran's
Beatrice.
iPad. Rudran's iPad. Isn't that a hand up?
There are 2 or 3 more questions in the chat as well. Let me just ask Beatrice Dias this question. Will the natural cooling cycle of the Earth set off some of the effects due to anthropogenic global warming?
This is an interesting fact because I think in the warming and the cooling, there's a natural cycle. Somewhere around the time that Al Gore gave his famous film, about 35% of the warming at that time was natural. 65% was man-made. But Al Gore, I think wrongly, said that 100% was man-made, and that was a mistake because at that time about 35% was natural. When I heard various other people tell the same thing, and when I confronted them, they said you can't tell a politician that it is 65% man-made and 35% natural because then they will be arguing about the percentages and not addressing the problem. So it is far politically better to say 100%. But I think that was wrong because by saying it is 100%, they had a lot of people who well understood that it was 35% was natural, and they exploited that to go against all that Al Gore talked about, which was to say that we need to think. And I think there is one problem is that that cycle, if you take around 1970s, then there was a cooling time and the warming thing, and we didn't have much global warming because the two things counteracted. I think currently the same thing is happening. We are not seeing very much warming because we are in a cooling phase naturally. But come about 2050, some of us will not be there at that time, when the warming and the cooling, the Earth's warming and the natural cycle is also warming at the same time, we are going to be in far worse position than we are now. So by the time, that is why people are talking about, what might happen in 2050, because at that time, we'll have the warming cycle, natural warming cycle, and the human warming cycle, which has not gone down, coming together and creating far more problems than it is creating now. So we are hopefully Donald Trump will not be there at that time and we'll take action long before that.
Thank you for that. And there's another question from Shireen Amendra. Shireen, are you here? There's thanks from Beatrice. Shireen, are you here? If you want to ask the question, or shall I read it?
Yes, thank you. Just read it. It's fine. I have another meeting.
Right. Shireen is asking, Kavan, what is your take on the entire universe being considered as a simulation?
That is the only explanation. If that is the case, then anything can happen. But science has been finding pretty much uniformity right across the universe. So if the whole universe was a simulation, you can't say that the Earth is just a simulation. It has to be the whole universe that is simulation, because we find the science the same on Earth as we find many billions of light years away. So I think if it was a simulation, it would have to be a global simulation of the whole universe. And then why pick out a small area like our Earth for creating life and our simulation? It's an interesting concept, but I think it's very unlikely to be case. But it is the only way. I have told a lot of people that you can get stupid things like astrology and everything to work. Because you can have anything working if it is a simulation. It depends on what you programmed in. Matrix is a film that actually explored this subject quite nicely, and I think it's an interesting science fiction movie. But reality-wise, I think it's difficult. I mean, we are getting to the point of creating life forms in terms of robots, which will in an AI, which in 100 years' time may be quite running around like R2D2 and C3PO. But are we also that? I think the biological, they will never be as matched to the biological thing of that we have, I think.
Yes, thank you, Kavan. It's and also Julian Barber has made some findings that there's no such thing as time and so on. That was discussed earlier, I believe.
What has what Einstein did in 1917, the general relativity of the thing has not been broken. We have to merge it with quantum mechanics and particle physics. But quantum mechanics and particle physics are almost merged now into the same theory. But the two big theories, which is the quantum electrodynamics and general theory of relativity, is far apart. People tried to merge the two in the 1980s. I can remember when I was at the Institute of Advanced Study, that was the big thing. And everybody said, in about 10 or 20 years, we would have all this sorted out and we'll know exactly the grand unification of thing. But 40 years are gone since, and we are no closer than we were in the 1980s of merging the big two theories of the universe. And maybe we are more closer in understanding the DNA, the biological universe, which I think is now bigger and more interesting than the physical universe, and maybe more understanding in how the DNA works and how that might come across something which we completely unexpected, which will teach us something which will help the physical universe. But now the expansions are and new knowledge is coming far faster from the biological universe than the physical universe.
Thank you very much. And thank you to the SLLI. I have to leave for another meeting. Thank you, Kavan. And thank you, SLLI.
Thank you, Shireen, for attending. And the previous question, which was about the matrix or do we actually exist, was tackled for the past 200, 300 years by philosophers. And Descartes' famous answer was ergo cogito ergo sum, which is I think therefore I exist, which is now being challenged by the current psychologists and philosophers. But that has been tackled by a different specialty, not exactly the physical scientists. It's more by um, um, philosophers. Are there any other questions?
Taika, do you have any questions?
Jaika was trying.
Yeah,
Where is he?
he's hiding.
Not really. I just made an
Ah, there
observation,
he is.
Kavan, about this. You did say about robots running around behaving like humans.
Yeah.
I think what is lacking in AI, as we call it, is actually it should not be AI that should be created. It should be artificial consciousness.
Yeah,
Is it-
AI is not that. AI is
Yeah,
still
AI.
AI is still an expert system. It's not really intelligence. If you have played around with ChatGPT, you can find out that it is not intelligent at all.
Exactly. Thank you.
So on that matter, Kavan, may I ask, I have this thinking about, okay, when there is an intelligent system, it can just do a lot of things. Now even if you look at a Tesla car, it recognizes anything which comes into close proximity, and it can horn. It can give a message to anybody who comes closer. So they can sense a lot of things. At what point do you think, or do you think, if we can develop the artificial intelligence to such a state where that intelligence tend to believe that there is an I in the sense self?
Yeah. I don't know. I think I asked ChatGPT whether the Turing test has been satisfied, and he said Turing test is old thing. We have said that AI satisfies that, but that does not imply that it is intelligent. That was one of the old tests from about 1950s. It was the Turing test, and that is, I think, gone. I don't know how AI works, but I have been using AI, but it is totally limited at the moment. But the improving in AI over the last 5 years has been enormous. It's explosive growth. Unless the AI bubble bursts before it grows beyond what it is now, I mean, I don't know how it's funded even, because I'm getting more work from ChatGPT than the $20 I pay a month for it. I don't know who is funding it. Somebody subsidizing it, hoping that it will come to a point where they will make a profit. But I will. If you know the limitations, you can get a lot of useful work done from it. But it is still very limited in what
There
you
was
can.
a discussion, I think last year or year before. I can't remember. I think it's maybe Google, one of the Google scientists, during when they were trying to introduce Gemini or some other artificial intelligence system. It started to do some.
Hallucinate.
Yes, yeah, and then
Hallucination.
something like that, wasn't it? It hit the headlines and it just
Yeah.
suppressed. What was it actually?
And I don't know, it goes on to weird modes and tells you
Weird.
stupid things. And even ChatGPT says in the instructions, say don't hallucinate it as one of the statements that you give it when you ask it a question, because sometimes it goes off on a tangent and goes or gives you some nonsense. And I have got it often when I forget to say don't hallucinate, it has gone off on a thing. But I will tell you something that I did with AI recently. Kalkande Dhammananda, right, gave my brother-in-law, I invited him to give a banner to my brother-in-law. And he did it in English, and I recorded it. And then I got a transcript of it from using YouTube. Then I gave it to him. I said, clean up the English and give me a publishable document. It couldn't do the whole 8,000 words when I gave it. Discussed with the problem, and it said, give me small chunks of 700, 800 words. So I broke it up into about 10 parts and gave it little chunks. It did a beautiful job on a very complicated subject, which I would have thought it would have been trained on, but it gave a beautiful job that I think the wording was far better than the wording that Galkande spoke, right? I mean, because when you're speaking, you're talking a lot of things, repeating things and all that, but it seemed to be that AI understood what he was talking and rewrote it in beautifully. I will send it to you. I sent it to Galkande to get his approval to post it online, and not got his approval yet. But it was amazing. I couldn't believe it. I sent it to a few people who read it and said, that sounds perfect. And that sounds what we heard. Not and if you look at the transcript and what is written there, the sentence structure is all different. But it picked up what was said and rewrote it without changing the context or changing what was said. And that, I think, was brilliant. And I don't know how he did it, but it was pretty good at doing it. And it was far more readable than reading the transcript and understandable. And when I sent it to people, they said, This is what we heard him say. So I chatted with ChatGPT and I said, isn't this like, you know, that famous time, that famous sentence that goes about that if all the letters inside a word is jumbled, you can
Yes.
still read it. Right. This is something like that on a more larger scale where the sentences are a bit jumbled here and there, and you can still get the meaning and rewrite it. And that's what I think AI was doing. It was reading all the words that were there, understanding what it was, and rewriting it in clearer English.
So basically, you're trying to explain the AI hallucinations, is it?
No. That is, hallucination, you have to strict it, because if immediately I gave it the 8,000 word, it went off on a tangent and gave me rubbish back.
Ah, right. Okay.
You you have to know its limitations. And
Yeah.
then I discussed with it. I said, you are giving me crap back. And then it sort of basically choked up. So then when I gave it small chunks of 500 words to 700 words, it did a beautiful job. So I had to cut it up very carefully so that ideas didn't cross. So we had a Q&A later on. So I had the question and answer. Each question and answer was given to the AI separately so that it could handle that question and answer properly. But I'm hoping that some lecture like this that I gave, I'll be able to basically get a transcript of YouTube, send it to AI, and it will make me a publishable paper.
Definitely.
Right?
Yeah.
I have done it to some of the interviews I did to various things, and it has cleaned it up very nicely. I'm amazed. I don't know how it does it, but it does a good job.
I was amazed. Just 2 days ago, I was rummaging through some rubbish and found, this Hana, one of my daughter's Hana, written in Sinhalese handwriting.
Yes.
So I just want to make fun of my daughter. So I just get a photograph and published it in our family WhatsApp group, saying that, okay, you need to pay me to interpret what's there. And and her husband just sent an English transcript within seconds. And I was amazed. I asked, how did you get this? This handwritten Sinhalese. And he said, Google Gemini. I was so amazed, that it can even read handwriting in Sinhalese.
Yeah. I have been getting it to read. There is Dutch archives of the minutes of the Dutch VOC, and I have been giving it, grabbing handwritten text of it, and it just very easily reads it and translates it to English. No problem. I gave it recently a currency note which had about 14 languages, including Arabic and various things. It took the whole lot, translated the whole lot, and transcribed it as well. AI's optical character recognition is pretty good.
Pretty good. Yeah.
Much beyond what we can. And it's English, but I won't tell that it is translation into Sinhala would be very good because it doesn't know very much Sinhala, but anything into English is pretty good.
Yeah. Ajay, do you have a question or?
Can you hear me?
Yes, we can hear you.
All right. Okay. Well, it's I don't know whether I should ask Kavan this. Anyway, I will. You took us through some catastrophic events that are sort of predicted, the solar storm, etc., etc. Can you hear me?
Yes. There is a disturbance.
Yeah.
Okay.
My question is, will science improve to an extent that humankind will be able to prevent some of these things like the solar storm, even the movement of the Earth's crust, preventing earthquakes, for instance, or asteroid hit and things like that. Do you think in maybe 1,000 years' time, if humankind still is in existence, will there be an attempt, or are people looking at how to prevent these catastrophic events that's we are waiting to face?
I think the asteroid thing is a manageable problem that we have. In fact, NASA is attempting to understand how to do that. And I think if we know of an asteroid which is going to hit us, we should be able to even now do that. We have the technology now to prevent it, right? If we have sufficient lead time, of course,
Okay,
which is lead time of maybe about 10 years, we should be able to prevent it.
that's
Uh,
great.
Right, but things like earth plate tectonics and volcanoes and that sort of thing is the energy requirements with things of those things are far larger than what we can think. Hopefully, we may be able to start predicting things to say, okay, we are going to have an earthquake in California in the next 5 years. We better do something about it. Now we don't know it will happen. We know it will happen in the next 50 years. We don't know anything better. So maybe, hopefully, we'll have our prediction systems of earthquakes uh, and volcanoes. Also, there's a lot of studies happening. We may be able to predict and maybe evacuate the area before damage is done. But I will tell you that I can remember of something dating must be about 50 years ago when they found a beautiful way of stopping the St. Andreas fault earthquake,
Oh,
which was to lubricate the fault and
wow.
create smaller faults, smaller quakes, which will remove the tension that over we would not have a large earthquake. We would have a series of hopefully inconsequential small quakes, which will release the tension that is building up now. Now we know the longer it takes, the bigger the tension that is built up, and the bigger the earthquake that will happen, right? Now we can reduce that. And they had a technology to do it by oiling the thing and doing something. But the thing that stopped that was not technology, but who was going to take responsibility for the smaller quakes? Because the insurance company will only take responsibility if it was God's action, right? If it was human action, even how good, how meaningful and prevention of a large earthquake, it was still human action which caused those smaller quakes. And who would be responsible for the damage created by those smaller quakes? And that responsibility was far more than could be taken up by the government, for example, to take that responsibility, and the whole project was cancelled. Right now, the insurance companies know if and when, and clearly it is going to happen sometime over the next 50 years, you have a huge earthquake in California and destroys half of LA, the insurance companies are going to go broke. So
Yeah,
they don't have to pay because they are going to be broke. They are not going to be able to pay. It will be completely liquidated and they would be bankrupt.
yeah.
So they are also taking that issue. A big one is of no harm to them. Small
Can you put forward the argument that man made God in his own image rather than the other way around?
I think it was completely the other way around. God was made in man's image, no question about it.
That's what I mean. Man made God in his image.
Definitely.
What about the solar storms?
Solar storms, I'm not sure. Maybe it will have to be shielding, right? We'll have to shield ourselves. There were sort of electronic solutions to that, which we might have to do to stop all the power stations going down and all. That was practical to, reduce the damage on power stations and the grid breaking down by a current and effect. That was not funded. Basically, because they didn't think it will happen someday, but we don't. It's not going to happen in the next 5 years, no, or hopefully it won't happen in the next 5 years. All the politicians think about is the next 5 years. They're not thinking about anything beyond that. Even if we take over Greenland, nothing will happen over the next 4 years. So Greenland.
Right. Yeah, it's the same thing about global warming, isn't it? They are reluctant to take those long-term decisions because of this the short-term thinking.
Yeah.
Yeah.
That's unfortunate. I mean, I don't think it's any difficult in Sri Lanka as it is in America or anywhere else. I mean, I thought America was a bit better. But I'll tell you one thing, that China is showing much more intelligence in this respect than US at the moment,
Right.
or has over the period. I think China is taking a very thing, and China is gaining by Donald Trump. Donald Trump is just doing what China wants it to do.
Yeah.
Get it?
Michael, did you have a question?
No, I would like to know the views of the audience about how responsible humankind is being by allowing measures for preventing action through climate change by just having voluntary systems of organized governments meeting and setting targets, etc., without any legal basis to it, to force people to do it. And should we have laws, or is it unethical to say that there are international laws which are designed to prevent the disasters? I know
Yeah,
it's probably not implementable, but are we being irresponsible by not allowing that to happen?
I mean, all the laws did not prevent
Venezuelan president being abducted.
Kidnapped and brought back as a prisoner of war. We had all the laws to prevent that, but it didn't prevent Donald Trump.
No. But that is true, Kavan, but that's not the point. The point is on a human basis of thinking, should we accept, although it may not be implementable, that we have a responsibility for future generations by enacting laws which are agreed on by whatever means it happens. It might take a long time, but are we being irresponsible by allowing nations to make their own decisions about this and not agree on a common pathway? Is that something we should at least aspire to?
We should definitely, but unfortunately, it needs leadership. And when one of the veto countries was completely off, removes themselves from the, then the UN becomes ineffective because they have veto powers to stop anything that happens. I think one of the things we should do maybe is to get rid of the veto powers, right? Because the Security Council can be there without veto powers, it will be far more effective than a Security Council with veto powers, because the Security Council with veto powers, nothing will happen. It will be NATO, no action talk only.
My reading is that we are irresponsible, but then human beings will always be that. I don't think we can ever be an ideal race. We can aspire to things, but I think we are not thinking enough of the future generations. We are being very narrow-minded, thinking ourselves and not thinking of the future generations. We should be far more conscious of the need to do various things now.
But saying that there's lots of environmental groups which are being almost militant now. And I think a few months ago, a GP was taken in front of the GMC, and the GMC decided to strike him off. I think she strike her off for repeatedly being in the environmental protest and repeatedly being jailed for obstructing roads, etc. So, there's this big fight going between the environmentalists and the governments as well. Who is correct? I don't
Greed
know.
will succeed. That's what, unfortunately, I see. Human greed.
Right.
Yeah, but at some point, maybe in the next 50 or 100 years, it will realize that we have to do something about global warming. Fortunately, it will be too late, and it will be much more costly and much more painful to people living in the coastal areas, but that's what it's going to be.
But Kavan, don't you think there is some movement towards that? I mean, if
Yeah, there is. I think we are talking about it a lot. I mean, and even though I blame Al Gore for telling a distorted view, his film did wake up the eyes of a lot of people and was, I think, politically useful to happen. But the momentum has gone away now because of this idiot in America.
Yeah.
You'll be the next in line for the abduction list, Kavan. Abduction list, you'll be next in line.
I bet I definitely won't go back to the US in the next 4 years.
Anyway, right.
Can I ask another
Sure.
more mundane question?
Go ahead.
Kavan, it's sort of worrying that there are so many landslides in Sri Lanka.
Right.
It was highlighted during the tour, but even before that, any rain, there were so many landslides. And about 10 years ago, when you were traveling through Sri Lanka, we saw huge numbers of truckloads of logs being transported down. We assumed that they were going to China, but I may be wrong. But on one of my trips, I counted about 25 lorries full of these logs, and I guess each lorry would transport about maybe 10, 12 huge trees. So we were wondering whether this increase in landslide is a result of rape of our forests and destabilizing the soil. This is a question that that has been in my mind, and I thought I might just put it to you. Is there a possibility that has happened?
Yes, deforestation happened when the British came and cut down all the trees to plant coffee and then plant tea after that. We destroyed an enormous amount of virgin forest in the area. It still happens now, but not at the scale that it was happening 150 years ago. I think we have two things happening. The rainfall, those days was in Indonesia, you used to find these huge storms coming to the middle of the Bay of Bengal, turning around and going back. Those are quietly becoming further and further westward, right? So we have now stuff coming across up to the coast of Sri Lanka, west coast, or maybe crossing Sri Lanka and going back. Over the next 100 years, these weather patterns is predicted to bloom the Sahara Desert, right? They are going to go right across and go into the Sahara, and you get rainfall in the Sahara. Even now, we are getting days where Dubai has been flooded, right? I mean, flash flood. I mean, those are once in maybe 10 years, but given time, these things are becoming far more frequent. And it's all global warming. I think definitely cutting the trees didn't help, but I think it is more currently the consequences of global warming that we are not fully in control of. And unless the world decides to stop this nonsense happening and does some concrete things to reduce the carbon dioxide concentrations in the world, which is creating this warming, we are going to have problems. So I don't think we are in control. I mean, clearly we can improve it by cutting less trees. I think we can also improve it by stopping all the burning of garbage. I mean, Sri Lanka is one country to burn garbage like nothing. I mean, I live in Mount Lavinia, where I have been fighting with the Mount Lavinia Hotel because they keep on burning all the temporary sheds that they make up, and then they burn all the stuff. If they don't understand, then how can you prevent the village, the people, other people also burning stuff because they can't bother to go and put it in the waste dump. There are lots of fires. You go up in the evening. For me, I see 2 fires every evening. And we can reduce a lot of that by banning burning of things, which is very simple to ban it, to make it illegal to burn things. I mean,
but is there an alternative recycling and
there is, but there is a certain amount of laziness, or or the fact that the truck driver refuses to take it unless he gets a santosa. So they say, I will burn it rather than pay a santosa. They do far more damage to the environment than the 500 rupees they are not paying the truck driver.
Okay. Well, that's your living experience. We only hear it from people like you.
I've been living in Mount Lavinia now for 20 years, and I got sick and tired of the Mount Lavinia hotel itself. I've taken them to the police as well, and they sort of stopped burning for about 3 months and forget all about it in 3 months' time.
When we were young, I can remember, my parents have this kunwood, and they just light the fire to it to get rid of all the leaves. Is it now not happening, you think?
It's still happening. It's still happening. Not as much as maybe it happened then,
Right.
but it's still happening, and that's the problem.
Yeah. Mm.
And some of the railway station also, they were setting fire. So I went and asked, railway station, what? No. The garbage truck doesn't come inside and pick it up. So the garbage, it should be taken out of the railway station and put on the road. These guys are too lazy to take it out of the railway station and they have to climb it up. If it is, especially if the bin is on the other side of the rail track, where they have to take it up a few steps and bring it across to this side and then put it on the road, they just set it on fire.
Mm. I think Sri Lanka. Sorry, yes. Who's that?
Sorry, you carry on.
Sati, yeah.
It's your friend. It's your friend. Can I digress a bit?
Yes, please. Yes, please. Yes, please.
Just to make a comment and get Kavan's opinion. It's a quasi-political plus philosophical combination. It's an observation, in fact. Now, we are perhaps rightly concentrating on the environmental issues.
Yes.
And we are worried about global warming and the consequences to be faced by humanity. And also you mentioned that I think it's a known fact which you repeated about the sun dissipating after 5 million years.
5 billion.
5 billion, yeah, sorry. Now, against that background, isn't it more likely that humanity will be destroyed by nukes itself? Given the way the world is behaving, particularly the superpowers. From history, we know that we have destroyed ourselves, regionally and otherwise, globally. And my feel is that we don't have to wait for the cessation of the sun power, because we are probably going to last only a few hundred years if the current trend in nuclear.
All I said was that the Earth will not get destroyed. Because whatever has hit the Earth over the last 4 billion years, whether it is gamma ray bursts or supernova extinctions or whatever, life on Earth has survived. Human life might not survive, but I'm sure life on Earth will survive any catastrophe till the sun goes off in 5 billion years. What happens to human race during the next 5 billion years? I doubt whether we can survive that long, because we have been creating problems at a much larger scale, rapid scale. I don't think global warming also would destroy us completely, because, I mean, once the population drops down to 1 million people, then there is no generation of carbon dioxide, and things will stay. And if 1,000 people could survive 74,000 years ago over a period of things to revive the human race, maybe we'll come back again in a couple of 100 years after a nuclear winter even. But whether we can, the only safeguard against a nuclear winter is to travel to Mars. That would keep us going if there is any drastic things happening on Earth. So I think this push to go and live on Mars or geo-thing Mars is a very good thing for the human race. Then we only have to have a problem is the sun, because we are far away from anything that happens to Earth. So we can support the Earth, and if Mars gets it, Earth will support them. So we are okay. So I think survival of the human species would require us to go to Mars very soon.
That takes me to another observation which you might have a view on. Now, you just mentioned about the human race being not there again, but perhaps in a different form. But we actually haven't defined the human race, have we? Now, given that if we believe in the theory of evolution, isn't it likely that even with the cessation of the sun, that we will continue to live perhaps underwater like phytoplankton?
No, the Earth will be destroyed entirely. The sun will grow to the size of the Earth's orbit, and it will just get completely destroyed. The Earth would not exist at that time. So that is the end, unless we have gone away. And even being on Mars is not going to be a help at that time when that happens. So at that time, we would either have to go and probably, terraform Titan or something if you are in our solar system to be sufficiently far away and safe from the sun. But then when the sun dies in another 100 million years, we won't have a sun. So we'll have to go off to some other solar system.
But you would expect water to be there, would you?
No. Earth is going to be inside the sun, to be completely engulfed by the sun at that time. When it becomes a red giant, the red giant's diameter is about the Earth's orbit. So the Earth just gets inside. It's a part of inside the sun to be completely destroyed. There is no Earth to talk about.
I have this nightmare of on that day when it happens, Sati will be there and saying, "I told you so."
But I'll be in Mars.
No, Mars is also not going to be safe when that happens, because the sun will be far too bright. I mean, Mars will be a bit safer than the Earth, but it's not good.
I will be in Mars with Rajapaksa's, not in Uganda.
I see.
Good. Yeah, in not Titan will be safe at that time. It will be sufficient. But even that to be short-lived, because the lifetime as a red giant is very much smaller. It's about 100 million years compared to 5 billion years. The evolution of stars, once they go off the main sequence, is only about a sun-like star is only about 100 million years after it goes off the main sequence. So there's not much longer when the sun disappears and becomes a white dwarf, and then we won't have enough energy for it to live. So anyway, there are a lot of things that will happen long before that, but hopefully, I think going to Mars is about the best protection against disasters on Earth, which includes human-made disasters on Earth. It's not easy, but maybe we'll do it in the next 100 years before we destroy ourselves completely.
That brings us to a nice conclusion, I think, and no more questions. And this is probably the time if you want to put on your videos, because this is the time to thank our esteemed guest speaker, Kavan, who's not a guest any longer for the SLLS. So thank you once again, Kavan, for this wonderful, wonderful enlightenment of what's in store in the near and distant future for the human race. Thank you so much on behalf of SLLS. Thank you.
Thank you. It was a pleasure talking about it.
Cheers.
You all enjoyed it.